Okay guys, now I'm going to speak about my favorite topic, exponents. I'm sure you will also enjoy exponents. It's a really very nice topic, a topic that makes you love maths. Okay, so exponents guys are shortened for repeated multiplication of the same thing by itself. For instance, the shortened for multiplying 3 copies of the number 5 is shown on the right hand side of the equal sign. 5 times 5 times 5 equals to 5 to the power of 3. Okay, we said the power is telling us how many times we multiply base, how many times we multiply 3. So 3 is going to be our power. The exponent, guys, the exponent or the power, you can call this 3 exponent or the power, same thing. Being 3, exponent being 3 in this example stands for however many times the value is being multiplied. The thing that's being multiplied, being 5 in this example, is called the base. So, well, I'm going to speak about this later on also, but now 5 is the base and 3 is the exponent. Okay. All right, so what is an exponent? The base raised to the power of n is equal to the multiplication of a n times. So a to the power of n, guys. A is the base, n is the exponent or the power. Equals to a times a times a times a times a equals to a, right, n times. So n is the number of the times we multiply the base, guys. A is the base and n is the exponent. So if we look at a few examples here, guys, 3 to the power of 1 is 3. Remember we said the first power of every number is that number itself. Okay, 3 to the power is 3 to the power of 2 is 3 times 3, which is 9. 3 to the power of 3 is 3 times 3 is 9 times 3 is 27. 3 to the power of 4 is 3 times 3 is 9 times 3 is 27 times 3 is 81. 3 to the power of 5 is 3 times 3 is 9 times 3 27 times 3 81 times 3 243. As you can see, guys, in these examples, also the power tells us how many times we multiply the base. Right, so power equals to a number written as a base number with an exponent. Base, exponent. So the number at the bottom, guys, 2 is base, 5 is exponent, right? So 2 to the power of 5 says 2 to the power of the fifth power, means 5 times. I'm going to say 2 times 2 times 2 times 2 times 5 times. The power, guys, the exponent tells us how many times we multiply the base. This is the base, the number that is on the top, and that is the exponent. Right, so guys, right, so when we are, guys, the exponent product rules, guys. So when you look at this first one, as you can see, guys, a to the power of n times a to the power of m. So when you look at this, you just have to figure out, guys, the a and a, right? The bases are the same. So the guys, exponents all about what you see in the question. You have to know all the rules so you know where to apply which rule, but you need to open your eyes when you look at the question. You need to see, guys. So when you look at this, you can say, okay, now, yeah, a and a, the bases are the same. So when the bases are the same, the rule tells me we add the powers. So a to the power of n times a to the power of m, because the bases are the same, I'm going to add the powers n plus m. So my answer is a to the power of n plus m. Right, if I have to do this with actual numbers, 2 to the power of 3 times 2 to the power of 4. Guys, 2 and 2 bases are the same. I'm going to add the powers. So equals to 2 to the power of 3 plus 4 equals to 2 to the power of 7. Right, then that is equals to, if 7 times you say 2 times 2 times 2, then it's going to be 128. Okay. Right, the other rule, guys, is when we have the same exponent but different bases. Now what we're going to do. When we have the same base and different powers, guys, we add the powers. When we have the same exponent and different bases, then we multiply the bases under the same exponent. As you can see, a to the power of n times b to the power of n, right? N and n. the exponents are the same. So I'm going to multiply the bases, a times b to the power of n. Now I'm going to illustrate it with the real numbers. 3 to the power of 2 times 4 to the power of 2. 2 and 2, the exponents are the same, so I'm going to multiply the bases, right? And then I'm going to write it under the same exponent. So 3 times 4 to the power of 2. 3 times 4 is 12. 12 to the power of 2 is 144. So guys, so here there are two rules we learn. A to the power of m, n times a to the power of m. When we have the same base, we add the powers. In the second one, we have the product rule with the same exponent. A to the power of n times b to the power of n. I have the same exponents. I multiply the bases. Okay. Right. So this is basically, guys, the same thing. A to the power of m times a to the power of n equals to a to the power of m plus n. Right, even if it's like this, guys, so there's no difference here, but the powers are the bases are the same, a over b. So what I'm going to do, a over b power plus m plus n. Okay, so when the bases are the same, guys, we add the powers, right? And this is also an example of when we have the same exponents. Obviously, we can multiply the bases. Right, I made it colorful. Maybe you understand it better, guys. That's why I have to repeat it. Okay, so a to the power of m times a, b to the power of m, a times b to the power of m, because m, guys, have the same exponent for both. So now if we have to do it with the numbers, guys, 3 to the power of 2 times 2 to the power of 2. I'm going to say 3 times 2 to the power of 2. So that's going to be 6 to the power of 2 is 6 times 6, which is 36, or you can leave it as 6 to the power of 2. 2 to the power of 5 times k to the power of 5, guys. As the same exponent, I multiply the bases 2 and k. 2 times k to the power of 5 will be 2k to the power of 5. Here I have p to the power of 3 times q to the power of 3. Again, I have the same exponent and multiply the bases p times q to the power of 3. So that's going to be pq to the power of 3. So now that was the exponent rule, guys, with multiplication. Now we're going to do the exponents, the division rule. The rules are easy, guys, with the division also. So with the division also, guys, when we have the same basis, right, say a to the power of n divided by a to the power of m. So if you think of this as a fraction, guys, this is the numerator, the top part of fraction. This is the denominator, the bottom part of fraction. So what we do is, guys, when we have same base, we take the power from the denominator, the bottom part, we subtract it from the top part. So it's going to be a to the power of n minus m. As you can see this example here, 2 to the power of 6 divided by 2 to the power of 3. This is numerator, this is denominator. So I'm going to take this 3 and subtract from 6. So it's going to be 2 to the power of 6 minus 3, that is equals to 2 to the power of 3, that equals to 2 times 2 times 2, which is 8. Now, dividing exponents with different bases. Now, what's going to happen when I have different bases but the same exponent? Okay, so guys, when I have this different base and same exponent, I'm going to do this a to the power of n divided by b to the power of n. As you can see, n and n are the same thing. So I'm going to say a divided by b to the power of n. 6 to the power of 3 divided by 2 to the power of 3. I have the same exponents, 3 and 3. So I'm going to divide 6 by 2 to the power of 3. So 6 divided by 2, and to the power of 3, guys, that is 3 to the power of 3. That is 27. Okay, so for the division rule, guys, when we have the same base, we take as you can see here, we take the exponent in the denominator, we subtract from the exponent in numerator, right? So as you can see here, a to the power of m divided by a to the power of m, a to the power of n minus m. When we have the same exponent but different bases, guys, then we just divide the bases, right, with each other, and then we write the exponent. So it's 6 to the power of 3 divided by 2 to the power of 3. 3's are the same, have the same exponents. So I'm going to say 6 divided by 2, that is 3. So 3 to the power of 3. I write the base, I mean the exponent as it. So 3 to the power of 3 is 27. Okay, so this is also, guys, same as what we did just now. A to the power of n divided by a to the power of n. I take this, subtract from n, so it's going to be, as you can see, guys, yeah, well, I can see this is the better format, because now we can clearly see that this is the denominator and this is the numerator. So we said what we do when we have the same basis. I have the same basis here, a and a. I take the power in denominator, subtract from the power in numerator, as you can see here, a to the power of m minus n. Okay, now what's going to happen when we have the negative power? What is this negative power? Or the negative exponent, guys? Negative, guys, again, this the power and exponent, guys, the same thing. Right, so negative 2 is the power of 5. Negative 2 is also the exponent of 5. So a negative exponent means how many times to divide by the number. Example, 8 to the power of negative 1 equals to 1 divided by 8. Okay, so now when we have the negative power, guys, that is not multiplication. Remember when we said we have the exponent tells us how many times we multiply the base, but when it's negative, now it tells us that we need to divide it. So we're gonna divide, right, the exponent by base. So, as you can see here, guys, 5 to the power of negative 2. Right, so that equals to 1 over 5 to the power of 2. So when you see the negative power, guys, all you need to do is say 1 over, write the same thing, but with the positive part. So 5 to the negative, 5 to the power of negative 2, I'm going to write it 1 over 5 to the power of positive 2. Okay, so you see the negative exponent, guys. This is, please do not forget this. This is very important. A to the power of negative n equals to 1 over a to the power of n, right? We're gonna have to remember this all the time, guys. So when you see negative power, guys, just say 1 over positive power. Finish. Right, so this example here, 3 to the power of negative 2, just add 1 over 3 to the power of positive 2. Okay, now this example, guys, please pay attention here. It's very important. When it's a fraction, then you have the negative power. You just need to fill up the fraction. So 2 over 5 to the power of negative 6 is going to be 5 over 2 to the power of positive 6. When it's a normal number, as you can see, guys, here, this one, 3 to the power of negative 2 equals to 1 over 3 to the power of positive 2. But when it is a fraction, right, with a negative power, guys, we just flip the numerator and denominator, right? Then we'll get the answer. So 2 over 5 to the power of negative 6, as you can see, 2 is on the top, numerator, 5 is denominator. Now I need to flip it, so it's going to be 5 over 2. 5 is numerator, 2 is denominator. And I change the power from negative to positive. Guys, this and this, please keep it in mind. Then it's going to be very easy for you to solve the rest of the questions. Right, there are a few other type of exponents, guys. We said this again, as you can see, guys, 5 to the power of 3, this is the base, this is the exponent. So here the exponent tells me how many times I multiply the base. Exponent is 3, so that means 3 times I'm going to multiply the base, 5. 5 times 5 is 25, times 5 is 125. This is the negative exponent we did just now. 1 over a to the power of negative 6, negative x equals to 1 over a to the power of positive x. If we do it on a real number, guys, it's going to be 2 to the power of negative 4 equals to, just say 1 over 2 to the power of positive 4. So the zero exponent, guys, a to the power of 0 equals to 1. We're going to see now zero exponent of everything, guys, is going to be 1. But zero exponent of 0 is not 1, that is undefined. Besides that, zero exponent of everything is going to be 1. I'm not going to speak about this. I can actually speak about that, but this is something you're going to see in grade 10. That's why I don't want to confuse you guys. I'm just going to leave it for now. Okay, so more rules, guys. We combine few rules. That's going to be like this: a to the power of x times a to the power of y. Same base multiplication rule, guys. Remember, we add the powers, right? as you can see, a to the power of 2 times a to the power of 3, a and a the same base, and the powers is going to be 2 plus 3, a to the power of 5. A to the power of x divided by a to the power of y equals to a to the power of x minus y, a to the power of 7. If we illustrate with real numbers, a to the power of 7 divided by a to the power of 3, guys, I'm going to say a to the power of 7 minus 3, which is going to be a to the power of 4. So the power rule, guys, when we have, you see now, the bracket, inside the bracket there's power, a to the power of x, x is the power. Now this is the power of bracket, so the power of power will be multiplied. So that equals a to the power of x times y. As you can see now, a to the power of 7 is in the bracket, 7 is the power of a, but there is 2 here. 2 is the power of what is inside the bracket. Inside the bracket is a to the power of 7. So the power of power, right? Then that is going to be multiplied. A to the power of 7 times 2 equals to a to the power of 14. Okay, this is, guys, the negative rule we spoke just now about it. The zero rule, again, is a to the power of 0 equals to 1. The zero power of everything is 1, except 0 power of 0, that is undefined. Right, so 0 power, we said is 1, guys. A to the power of 0 is 1, unless a is not equal to 0, because we said if a equals to 0, that's going to be undefined. Okay, you can see here. Right, so all these examples, as you can see, no matter what they are inside the bracket, that is going to be 1 as long as they have power of 0. Okay, so power of power, guys, we did just now, a to the power of m to the power of n. Power of power, a to the power of m times n. As you can see the examples here, 2 to the power of 3 is inside the bracket, the power of 4 to the power of 3 times 4. That is going to be 2 to the power of 12. N to the power of 2 is inside the bracket, power of power, again, is another power, so it's going to be multiplied. No matter how many powers you have, guys, the power of power, if there is another power here, then it's going to be multiplied again. So the power of power will be multiplied. N to the power of 2 times 4 is n to the power of 8. Okay. Okay, so guys, now when we have something inside the bracket, guys, and there's a power on the bracket, that power on the bracket is the power of everything inside the bracket. So I have a times b inside the bracket, and m is the power of the bracket. So that means that is a to the power of m, b to times b to the power of m. So the m is power of a and b. So this is equals to a to the power of m times b to the power of m. Then we see the power outside the bracket needs to be applied to all bases inside the brackets, guys. So as you can see here, guys, again, I have a bracket. Inside the bracket, I have the terms, and then there is a power of bracket. So this 2 here, guys, is the power of 2 and the power of a. So 2 to the power of 2 times a to the power of 2. That equals to 4 times a to the power of 2. So it's 4a to the power of 2. Okay. So the power of power in division, guys. So when you see any division like this, guys, 3 to the power of 2 to the power of 4 divided by 3 to the power of 3 to the power of 2. So same thing, guys. First, we need to work out the power of power. So that's going to be 3 to the power of 2 times 4, 3 to the power of 8 divided by 3 to the power of 3 times 2, which is 3 to the power of 6. Okay, as you can see, as illustrated here, guys, it's going to be 3 to the power of 8 divided by 3 to the power of 6. Then apply the rule, the division rule, guys. Take the 6 and subtract from 8, so it's going to be 3 to the power of 8 minus 6, that is 3 to the power of 2. Okay, so that's it about the exponents. I'm going to do all the questions, guys, in the textbook. All right,